Section 3.3, Implicit Differentiation and Related Rates. This section will use the method of implicit differentiation to solve for a derivative and apply the method of implicit differentiation to solve for a real-life rate. Implicit differentiation. In general, we do not need to know the explicit representation for y in order to obtain dy by dx. For example, x squared plus y squared equals -1. This is implicit function. If we have y equals 2x minus 5, this one is called explicit. In the past, we have done derivative or dealing with the explicit term. In this section, we will find the derivative dy by dx where the function is in the form of the implicit function. Example 1. Given that the equation x squared plus y squared equals 25, find dy by dx and then evaluate the derivative at the point 43 and the point 05. We are going to find the derivative, which is dy by dx. Our equation is x squared plus y squared equals 25. The derivative is the derivative of the y with respect to x. So we are going to find the derivative of each term with respect to x. So d by dx of x squared plus d by dx of y squared equals d by dx of 2. And since we are going to find the derivative of each term with respect to x, we treat them the same way. The derivative of x squared with respect to x would be 2x. But the second term, the derivative of y to the second with respect to x, y is the function that we don't have to solve for it, but we know that y is not the same as x, but y is another form of the function in terms of x. Okay, but embedded within the implicit function form. So the derivative of the y squared with respect to x, we kind of apply the chain rule to find the derivative as a general power rule. So it becomes 2y and then multiply by dy by dx equals the derivative of the 2, which is 0. Our goal is to find dy by dx. So then we are going to solve for dy by dx by subtracting 2x both sides, dividing both sides by 2y. That gives us negative x over y. Now we have dy by dx as negative x over y. So we find the derivative dy by dx for the point 4, 3. That means if x is 4, y gonna be 3. At that particular point, the dy by dx would be negative 4 divided by 3. And for another order pair, dy by dx at the point 05 going to be 0 divided by 5 or just 0. Let's see the graph. The equation x squared plus y squared equals 5 is equals 25, sorry. X squared plus y squared equals 25 is the circle with the radius 5. At the order pair 4, 3 and the order pair 0, 5, the derivative, the dy by dx, add the order pair 4, 3 gives us negative 4 over 3, which is negative slope or negative value. In the earlier sections, we know that dy by dx is the slope of the tangent line. That means the tangent line of the curve at the point 4, 3 has a slope m as negative 4 over 3. Another order pair dy by dx at 0, 5 equals 0. That is the slope of the tangent line passing through the point on the curve which is 0, 5. Okay, since the slope is 0, that means the tangent line is the horizontal tangent. Let's look at this example. If we have x times y plus x squared times y to the third minus 1 equals 0, find dy by dx. Another implicit function. As x and y all over the place. To find dy by dx of the implicit function, we are going to use the notation dy by dx and apply to all terms. So d by dx of x times y plus d by dx of x squared y to the third minus the d by dx of 1 equals d by dx of 0. As you notice, x times y and x squared times y to the third, those are product. So we are going to apply the product rule when you find the derivative. And I note here the product rule, u times v, the derivative is u times v prime plus u prime times v. The order doesn't affect to the product or the solution because it has the property that you can switch them. Like u times v is the same as v times u, or a times b is the same as b times a. So for the first one, the derivative of x times y with respect to x, that would be the first term, which is the x, multiplied by the derivative of the second term, plus the second term times the derivative of the first term. Similarly, for the second product, the first term x squared, the derivative of, let's do it step by step, the derivative of y to the third, and then minus, plus sign y to the third, multiplied by the derivative of x squared. Close it. The last term, the derivative of 1 is 0. The other side of the equation, the derivative of 0 is 0. Next, we just clean up x times dy by dx plus y times dx by dx, which is 1. And for the second group, we have x squared. The derivative of y to the third is 3y to the second dy by dx. Again, the y is the function, or in some terms of x, which we don't have to solve for it, since we are working on the implicit function. And then the next term, y to the third times the derivative of x squared, which is 2x, equals 0. Now, let's simplify x dy by dx plus y plus 3x squared y to the second dy by dx plus y with 2 times x times y to the third equals 0. Your goal is to find dy by dx. Therefore, we are going to collect the term that contains dy by dx in the same side. Then we have x added with 3x squared, y squared. Both of them multiplied by dy by dx, and the other terms go to the other side, or by subtracting those terms. So those terms will appear on the other side. Equals y plus 2 negative y minus 2xy to the third. And then divide both sides by the quantity x plus 3x squared y squared to get dy by dx as negative y minus 2xy to the third divided by the quantity x plus 3x squared y squared. For this example, we find dy by dx if we have square root of x minus square root of y equals 16 as the implicit function. Let's rewrite the square root as a power. We have x to the power 1/2 minus y to the power 1/2 equals 16. To find dy by dx, starting with finding d by dx of each term. The derivative of the x to the power 1/2 with respect to x is 1/2 x to the negative 1/2. And the second term, we get 1/2 y to the negative 1/2. And don't forget to multiply by dy by dx because this one gonna need the chain rule since y is some kind of function that we do not have to solve for it. But we know that y is just some kind of function in x. So that's why the chain rule is applied when you find the derivative involving the y terms. The right hand side, the derivative of 16 is 0. Now we have the term that contain dy by dx, only one term. For our convenience, both terms multiply by 1/2. So we just multiply all by 2. Let's clean the problem up a little bit. It becomes x to the negative 1/2 minus y to the negative 1/2 dy by dx equals 0, or x to the negative 1/2 equals y to the negative 1/2 dy by dx. And negative power mean the reciprocal. So 1 over square root x on the left equals 1 over square root y on the right, which multiply by dy by dx. Now we are going to solve for dy by dx. So dy by dx alone, we have to get rid of the 1 over square root y by multiplying both sides by square root y. Therefore, dy by dx, we get square root y divided by square root x.